Welcome back to another explainer. Look, if you're gearing up for the Florida Certified General Contractor Project Management exam, you already know the stakes are just incredibly high. Literally, one single topic can be the difference between getting your license and having to retake the entire grueling test. So today, we're laser focusing on the BSCI Wood Truss guidelines. And hey, this isn't just about dryly reading code. It's about mastering the exact numbers, the tolerances, and those sneaky liability traps the state expects you to know cold. Let me ask you something. When a wood truss snaps on site, who is legally to blame? I mean, it's super easy to point fingers at the manufacturer, right? Or maybe the delivery driver? But listen, the state of Florida, they don't care about excuses. When that wood splinters and the roof caves in, the liability falls squarely on one person. And for your exam, you absolutely need to know exactly who that is. Okay, let's dive into this. On your exam, the legal definition of the installer is the licensed contractor who pulls the building permit. Yep, that is you. From the exact moment those trusses arrive, you bear total liability for the proper receiving, unloading, sorting, storing, handling, insulation, and bracing. The whole shebang. The engineering might be done in a fancy factory, but the legal burden of making sure that roof doesn't fall down, that rests completely on your shoulders. To help you memorize this dense material, we're going to follow the chronological journey of a truss on your job site. First, the receiving gate liability. Second, site storage and logistics. Then, crane lifting support intervals. After that, primary causes of collapse. Fifth, plumb tolerances and geometry. And finally, ground bracing splice rules. Let's trace this step by step so it's all locked in for test day. All right, our journey begins the moment that delivery truck rolls onto your dirt. Step 1, the receiving gate liability. Your risk starts right at delivery. See, the installer is legally required to inspect the trusses for structural fractures or damage at the immediate moment of delivery. You absolutely must perform a manual piece count check against the delivery ticket. Why? Well, if you fail to catch a split wood cord or say they shipped you the totally incorrect lengths and you don't flag it right then and there, you just bought it. You assume full liability for all those construction delays and order reruns. You own the mistake. Okay, so once you've accepted the delivery, the trusses are off the truck. So, how do we legally store them on site? Let's move to step 2, site storage and logistics, specifically the rules for horizontal storage. Now, what's really interesting about this exact excerpt from your study guide regarding horizontal storage is that it asks what to do if trusses are to be stored horizontally for more than 1 week. This specific time frame, more than 1 week, is the absolute trigger for a strict blocking rule on your exam. So, lock this exact answer into your brain. If they're stored horizontally for more than a week, blocking must be placed beneath the stack at a maximum interval of 8 to 10 feet on center. Got it? 8 to 10 feet blocking intervals. Write that down. Let's see how this builds as we actually get the trusses in the air. Step 3, crane lifting support intervals, or the span matrix. You've got to think of a truss kind of like a fragile puzzle rather than a solid piece of wood. If it experiences excessive bending, the integral teeth of the metal connector plates will literally pop right out of the lumber. Once that happens, its structural integrity is completely destroyed. To prevent that bending, the exam tests you on 3 escalating span thresholds. First, during transportation and offloading, trusses must be physically supported at horizontal intervals of 25 feet or less. Second, if you're using a mechanical crane for an open span exceeding 30 feet, a dedicated spreader bar is required. And third, this is a big one, for heavy span trusses exceeding 60 feet in length, a specialized strong-back spreader bar is absolute mandatory law. 25, 30, 60. Memorize that escalation. But hey, what if you're installing them by hand? Well, the STE tests this deflection rule too. During manual manipulation, any lateral, out-of-plane deflection that exceeds 3 inches inside a 10-foot span, that means the truss is legally classified as structurally excessive and unsafe. So 3 inches per 10 feet is your absolute limit. Even with the best offloading, things go wrong. That brings us to Section 4, primary causes of collapse, specifically field errors. According to expert John Bees, the structural integrity of a truss relies on exact geometry. He stresses that the vast majority of wood truss failures, they aren't engineering design faults. Actually, they're caused by field installer error during erection. Here are the core causes of collapse you need to chunk together in your memory. We have inadequate temporary bracing, weak bracing connections, improper field alterations like, cutting or drilling into a truss, installing broken trusses, and misalignment, basically out of plumb walls. But I really want to draw your attention to that very top item, overloading with plywood prior to bracing. So the crucial point is this. The single most common field failure occurs when installation crews place dense stacks of plywood sheathing on top of trusses before the permanent or temporary bracing has been completely secured. For pure rote memorization, if the exam asks for the most common cause of collapse, it is overloading unbraced trusses with building materials. Don't forget that one. Okay, now we're finally setting the trusses. This is Section 5, Plumb Tolerances and Geometry, basically keeping it vertical. Engineered trusses rely entirely on strict vertical geometry. That physical force is literally the only thing keeping the roof over your head. And this brilliantly illustrates the strict plumb tolerance formula. Installed wood trusses must not deviate from a true vertical plumb alignment along any point of the truss depth by more than 1/50th of the truss depth at that point, or 2 inches. But here is the critical exam trap, so listen up. The legal limit is whichever of these two measurements is less. Always remember that. You calculate the 1/50th, compare it to 2 inches, and the smaller number is your absolute legal limit. We've made it to the final step of our journey, Section 6, Ground Bracing Splice Rules. Prepare yourself because I'm going to drop some rapid-fire numbers on you that show up heavily on the state exam regarding ground bracing splices. 10. If you're constructing ground bracing splices using wood members, 10 is the absolute minimum number of 16 penny or 16D nails required to secure that connection. 3. Immediately following those nails, 3 feet is the minimum horizontal overlap required for that exact same wood splice. 10 16 penny nails and a 3-foot minimum horizontal overlap. But wait. Where can you actually put these splices? Let's slow down for a second, because this vital geometry rule will absolutely trick you. Splices along a ground bracing run are legally permitted only at points that are already laterally braced. You cannot legally splice a brace just floating in the middle of nowhere. It must be anchored to an already braced point. Finally, beware of the engineer out trap. Historically, exam manuals specified exact generic nail counts for every structural brace. Well, not anymore. Due to massive structural litigation over collapses, standard manuals now default to a strict rule. All bracing connections must be made with the exact number and type of nails specified explicitly by the truss designer or licensed engineer. Generic manuals just don't protect you in court anymore. The engineer's exact spec is absolute law. Which leads us to our final thought. If you deviate from the engineer's exact spec by a single nail, if you use 8 instead of 10 or leave out a spreader bar at 35 feet, and that roof falls, what happens to your GC license? And your livelihood. Mastering these numbers isn't just about passing the Florida exam, it's about protecting your entire career. Keep studying, lock these rules in, and you'll crush it. See you next time.